So this unit's all about exponents and exponential functions and logarithmic functions. So we talked about exponent properties, and we did some of that. We solved equations using properties of exponents, and so now we're just going to move into what's happening with an exponential function. So learning target 4 is just graphing exponential functions and inequalities. You've done that before, or remind you how. And learning target 5 and 6, we're just doing 5 today, but learning target 5 and 6 are both different formulas using exponential functions to talk about growth and decay. Okay? So for learning target 4, just remember that an exponential function is any function where there's a variable in the exponent. That's what the definition of an exponential function is. So we have the base and we have a variable, and so then we are going to have a continuous curve, all right? And those continuous curves are going to have an asymptote that they're not going to cross. And we'll talk about why in a second. Okay? So I've got 3 examples. We're going to graph all of them. All right? I'm going to do it by hand because I want to show you how some things work. But then, again, if you need to check things in your calculator, you could. Okay? So for the very first one, we have y equals 3 to the x power. So this is like any other function. If you're not trying to graph something, you can use a table. So we can pick some values for x. Now, because it's an exponent, once you start increasing, you're going to start increasing very quickly. So you don't have to use a lot of values to get very large very quickly. I want to make the point, though, about negative exponents, what we know about them. So if I plug negative 2 into y equals 3 to the x power, I get 3 to the negative second power. But I know that's really 1 over 3 to the second. That's really 1 over 9. So that's a fraction, right? Same thing when I do to the negative first. I get 1 over 3, which is a fraction. So if I kept using negative exponents, like negative 3, negative 4, negative 5, negative 6, I kept adding a negative exponent, I would keep getting a fraction, right? And it would get smaller and smaller, but would I ever actually reach getting 0? No. So in this case, we're going to have an asymptote. It's not going to cross the x-axis because there's no way for it to. Right? All those values keep getting smaller and smaller and smaller, but they're never actually going to hit 0. So 3 to the 0 is 1, 3 to the first is 3, and 3 to the second is 9. So I can graph these points. Like I said, they get large rather quickly. So all the way over here, all these negatives are going to be hugging where it's the x-axis, but it's not actually going to cross that. And then it's going to increase. You need to think about those things. The exponential function is a curve. It's not a line. Don't just graph 2 points and draw me a line. It doesn't work that way. Any questions about where that came from? The second example then is very similar, but has a negative exponent. So again, I want to talk about what happens with that. Any questions about the first one, though? All right, on the second one then, y equals 3 to the negative x power. Very similar idea, but right, so you're going to have double negatives, so it's going to be increasing and decreasing in the opposite direction, right? So last time we were increasing as we approach larger values of x, and now we're going to be decreasing as we approach larger values of x, because our fractions are now going to be where you had positive x values, right? So 3 to the double negative second is just 3 to the second. Just be careful when you're doing these that you watch what the order operation says and you watch what your values say. Okay? The reason I say that is because of negatives that could occur. So if I change this and I had y equals negative 3 to the x power. You guys all know how to do that. It's not a big deal. But you're going to have a negative 3. So watch out for what's happening with that. If you have y equals negative 3 to the x power, that means something different because of the order of operation. So for the first one, y equals negative 3 in parentheses to the x power. You take the negative 3 and raise it to that power. In the second one, you do 3 to that power and then multiply by negative, right? Just make sure you're watching the order of operations. You guys know that, right? You do exponents first, and then you would do multiplication or division. So that's why in the second one, you do exponents first, so there's no parentheses, and then this is like multiplying by negative 1. Just be careful. All of these functions still follow all the same rules for all of the functions you learned in Algebra 1 and Algebra 2 about all their transformations. If I decide to add 4 at the end, that just means I'm going to shift this entire function of 4, right? If I add 4 to the exponent, well, then it's going to be shifting right and left. All right, so just be careful. Any questions, though, about how to graph them? Make sure you take your time. We're also graphing inequalities. So same thing, but then we have to watch out for where we're shading, and we have to watch out for dashed and dotted boundaries, right? There were a few of you, there's like a little less than a fourth of you from all of my classes, that on the take-home quiz, on the very last question, the circle was a dashed boundary. So there were some of you that just forgot. So if you got like a 39 out of 40 or something, a lot of you guys did that because you forgot to make it dotted. Just watch out for the symbols. Make sure you're paying attention closely. So for this one, I don't know why I put x, y first. With x, y, we have some values we can use for x. We want to do 2 to the x power first, then subtract 4. If I do 2 to the negative second, that's 1 over 2 to the second, or 1/4. So you have 1/4 minus 4, negative 3, and then 3/4. One half minus 4 is negative 3.5. 2 zeros 1, and 1 minus 4 is negative 3. Two minus 4 is negative 2. 4 minus 4 is 0. 8 minus 4 is 4, right? So in this case, again, same thing with the fractions. You have 2 to some negative power, you get this fraction, and you're taking that fraction and subtracting 4. You're always going to get negative 3 and something, negative 3 point something, right? So we're never going to cross the line y equals negative 4, right? It's going to get closer and closer to that line, but it's never going to cross it. Just keep that in mind, because I will look at your graphs carefully on the quiz. So we have negative 2, negative 3.75. That's at negative 3. Negative 1, negative 3.5. 0, negative 3. 1. Oh, I'm not graphing this in the right place. I was doing 2. There we go. 2, 0, 3, 4. So we're going to hug this line and never cross y equals negative 4. Then it's an inequality. It says greater than. So this should actually be dashed or dotted, right? You just pay attention to your symbols. And then it says greater than. So where do you think that means you're going to shade? Above. And so if you aren't sure, we can always use a test point. So we can use 0, 0. We already put 0 in for x and got negative 3. So is 0 greater than negative 3? Yes. So we could shade everything up here. Questions about graphing any? I didn't give you any graph paper yesterday, so I do have graph paper for you to graph this learning target. All right. And then learning target 5, we're using this idea of an exponential function to finish some exponential growth and decay problems. So you have 2 different equations here. You will get the equations on the quiz. However, I will not explain to you what all the variables and all the equations mean. That's up to you. Okay, but you will get the actual equation. So the first one is for basic exponential growth or decay. If something is growing or decaying exponentially, we can use this formula. So you have n, which is just the final amount of whatever you're dealing with. Final amount of money, final amount of deer, final amount of chicken, whatever it happens to be. Okay? Just never know. N sub 0. That's the initial amount. That's how much you start with. Then you have 1 plus r, where r is your rate of growth or decay. Some comments about r. R is positive if you're talking about growth. R is negative if you're talking about decay. Also, R should always be given in decimal form. They'll probably report it to you as a percentage, but in the formula, it needs to be in decimal form. So if they say that something's appreciating at a rate of 17%, make sure you put 0.17. And then T is your time, and it has no bearing on the units. It doesn't have to be converted to anything. It can be years, it can be days, it can be weeks, it can be months, whatever time you have. Questions about any of those variables? Then a more specific equation is for compound interest. So specifically talking about money, and specifically talking about money growing interest. So R is always going to be positive. We're talking about everything growing here. You have A equals, well, just like N equals. So A is your final amount. P is your principal amount or your initial amount. You have 1 plus R is still a rate, and it's always going to be positive because we're talking about growth. But then you have N in 2 places. N is the number of times the interest is paid or compounded each year. So if it says that it's compounded quarterly, how many times per year is that? 4. So N will be 4. If it says it's compounded semi-annually, that means it's compounded twice per year. So N would be 2, etc., etc. All right? Then T is your time, but here T has to be in years. So if they tell you this is happening over 6 months, that's only half a year, so T would be 0.5. So in the case of compound interest, T has to be in years. Questions about that? For the problems, though, mostly you're just substituting your values in, though, and calculating. The actual problems aren't that bad. Everyone good with all the variables? All right, first example. Business owners keep track of the value of their assets for tax purposes. Suppose the value of a computer depreciates at a rate of 25% a year. Determine the value of a laptop computer 2 years after it's been purchased for $3,750. So here we're just talking about growth or decay. We're not talking about money in like an interest account in a bank. So we're not doing compound interest. So you're using this equation. So what does the computer or the laptop initially cost? $3,750. Are we talking about growth or decay? decay. It says depreciate. So we're going to have a rate that's negative. And what is our rate of decay? 25%, so 0.25. And for how long is it depreciating in this problem? 2 years. Just to fill all those values in, but then it's just a matter of figuring out this in your calculator. Again, make sure you follow the order of operations. So you have 0.75 to the second power times 3750. Now in this case, we're talking about money, so make sure you round appropriately. So the computer's approximately worth $2,109.38. Always round according to the context of the situation. If you're talking about depreciating deer population, if you get n equals 357.5, well, you can't have half of a deer, all right? So just make sure you think about that. Okay? Question. All right, the other example then, we're talking about compound interest. It says determine the amount of money in a money market account providing an annual rate of 5% compounded daily. So it's telling you how often it's compounded. That's a requirement of those problems. If Marcus invested $2,000 and left it in the account for 7 years. So you have this equation instead, compound interest equation. So how much was initially invested? 2,000. And we're always talking about growth. What's your rate of growth? Let's see. 5%. How often is it being compounded? Daily, so what's in? 365. It's how many times it is per year. So if it's being compounded daily, that's 365 times per year. We use that same number in the exponent times the number of years. How many years? So, $365 times 7. Just keep that in mind. We got 0.05 divided by 365 plus 1. In the parentheses, we're going to raise that to the 2,555 times 2,000. So 2838.07. Questions about how that works? Did you do it in the right order? You should do the parentheses first, so 0.05 divided by 365 plus 1. And then to the 2,555th power. Do you do that in parentheses? Because if not, it probably didn't do it all in the exponent. So be careful with your calculator. There we go. All right. Any questions?